Hello, ladies and gentlemen. Let's get some algebra practice in and kind of discuss a little bit more about what vectors are. So here we have our vectors. Down here, we have a right triangle with an adjacent side, an opposite side, hypotenuse, and theta, which is our angle. If you need some review, understanding what these are, what a hypotenuse, the adjacent side, the opposite side, and what theta is, please watch our video from the 17th. That's on our Jigsaw page. All right, so what exactly is happening here in this diagram? Well, let's say we have use a different color. We'll have a man, a stick figure. And here we go. We'll give him some eyes, and he's really happy to be helping us out today. He loves vectors, yay! And what he's done is there is this big building right here, and he wants to get around. He wants to come over here. There is this this awesome video game store that he wants to go check out, GameStop, right? Because that's still a thing. But unfortunately, he can't walk directly there. He can't walk directly to GameStop because there is this large building in the way. Oh no. So what does he do? Well, he has to go ahead and walk all the way around this building to get to that GameStop. So he has to come down here and he'll walk in one direction, directly east. We don't know how far he's walked, but that's something we'll get to in the next section. So he's walked directly east, and now he has a straight path directly north to the GameStop. So we want to draw our second vector. We want to make sure that we start where he's at. So we'll just draw our vector straight up where he's at. And now he walked directly north that time. So I'll go ahead and I'll label that. Let's get rid of this circle. We don't need that. So he went and he walked directly north. And let's go ahead and just change the color on that just so it stands out a little bit easier for you guys. So the first vector he walked was directly east. The second vector was directly north. And we want to figure out, okay, how far he is from a starting point. What's his displacement? So first we draw a line, a straight line from our starting point, which is right down here, to the GameStop, which is right up here. So we'll draw a straight line. There we go. And that is our resultant vector. Our resultant vector is designated by that red line. And we want to figure out how long or how much of the displacement there actually is. How far is he from that original point? And we can do that by using the Pythagorean theorem, which is just a squared plus b squared equals c squared. And we don't have any of, we don't have any numbers for our triangle right here, but we can come over here and we can actually get some of these numbers. So let's go ahead and let's look at this one down here. Cosine of theta, which is just our angle, the cosine of theta equals 28 over 23. And what that's telling us, it's telling us when we look at cosine, that's telling us two things. It's telling us the adjacent side and the hypotenuse of angle theta. So let's clean this up a little bit. Oh no, he lost his head. All right, so I'll clean this up a little bit, and now we can see our vectors a little bit easier now. All right. And you know what? Let's not use that one. Let's not use the cosine. Let's in fact use the tangent. The reason why I'm using tangent of theta is because the tangent gives us the opposite over the adjacent. And the reason I want to use the opposite over the adjacent is because I know what my opposite is. That's the side I walked. I walked north that way. And I'm using the adjacent side because that was our first direction that we walked. That was west, right? Or sorry, not west, but east. So we're going to be using these numbers for our diagram. So our tangent of that angle theta equals 9 over 19. Well, we can come up here and we can see that 9 would be the opposite, and the opposite side of our angle theta is right over here. It's labeled, and that is 9, we'll call it 9 meters. Kind of far, but not too far. And so then our adjacent would be 19 meters. So now we have the A and the B of our right triangle. We can go ahead and plug those numbers in to our equation. It doesn't matter which number we put in for A or which number we put in for B, because C is always going to be the hypotenuse, and that is our resultant vector, the one we actually want to find. So A is 19 meters. We're going to square that. And then we add B, it'll just be 9 meters. That's our opposite side. Not B. It's 9. Let's clean that up. We have 9 meters, and we will put that in parentheses and square the whole thing. Remember, we want to put it in parentheses because sometimes we might have a vector that goes south, and that is typically a negative number. So we don't want to have any negative numbers. So when we square a negative, that negative goes away. So get used to putting our values in parentheses, okay? And that'll help us when we plug it into our calculator. And that equals C squared. So I'm going to go ahead and plug it into my calculator right now, and I get 19 squared is 361 meters. 9 squared is just 81 meters. And that equals our C squared. But we want to go ahead and find what C is by itself. So we have to take the square root of C, and we have to take the square root of the sum of our first two integers. So we can take 361 plus 81. That gives us the square root of 442. That equals our C. And C equals 21 even. All right. So that's how long our hypotenuse is. It's 21 meters. Sorry, we need to have our units there. It's really important. So make sure that you are putting your units down. 21 meters. But that's not what we were asked to solve for. We were asked to solve for theta. So can we go ahead and solve for theta? Yes, we can solve for the direction that he traveled. He traveled, if we look at this, he traveled east, and he traveled north, and so he traveled northeast. But we want to figure out just exactly how much he traveled northeast. We want to be very accurate. We could say, yeah, he traveled 21 meters northeast, but we want to know exactly where he traveled because this yellow line is northeast, right? And this yellow line is northeast, and this yellow line is northeast, but he didn't travel any of those. He traveled this way to get to that GameStop. That's how far he is. So we want to be sure, we want to be very accurate with our measurement. So how do we figure out that angle? All right, let's just clean this up a little bit. There we go. Our stick figure is disappearing little by little. He's losing his body. All right. So how do we do that? Well, we know what the opposite side is, and we know what the adjacent side is, right? That's given to us right down here. It's 9 and 19. So the opposite side is 9. The adjacent side is 19. We don't know our angle. We don't know theta, but we want to figure it out. And so which one of these equations is going to let us solve for theta if we know the opposite and the adjacent? Well, it's going to be the tangent. Now, I set that up for us already. And so all we have to do is rearrange this equation so that we can plug it into our calculator and find that angle. But that will be a video for next time. All right, guys, have a great day, and I will see you later.